Hello, everybody, and welcome to a lesson on volume of pyramids and cones. This will be lesson 11.7 in the textbook, if you're interested in checking it out. For now, pause your video, come on back when you're ready. That's the first page, on to the back page. Again, pause and come on back when you're ready. So here is our goal. We've done volume before. Actually, we've done 1 dimension, 2 dimension, and 3-dimensional measurements. So far, we've only done volume of rectangular pyramids and cylinders. Today, we're going to focus on pyramids and cones. Forgive me if I said pyramids instead of prisms. Prisms and cylinders have been before, pyramids and cones, and eventually we start putting some shapes together. For instance, those of you that know what a silo looks like on a farm will be 2 shapes. Will we add or will we subtract the 2 shapes? That's where we are heading. Go ahead and pause your video. Come on back when you're ready. And a note, do not use 3 and 1400ths for pi. We have a nice pi button that'll give us a more accurate answer, so that's what we're going to do. Now, I'm going to go ahead and show you how to find the formulas for the volume of a right circular cone and the volume of a regular pyramid. Now, I'm pulling these videos off the internet. I'm hoping this works. So let's go ahead and see if you can take a little look-see, huh? So there's one pyramid that fits inside its prism. Second pyramid. Third, 3 pyramids fit inside that prism. Now, let's take a look at the similar thing with a cylinder and a cone. One's cone fits inside. 2. Wait a second. We seem to be seeing a pattern. This is a triangular pyramid fitting into a triangular cone, or triangular prism, excuse me, and there it is again. It just keeps happening. 3 of these pyramids will fit inside, the volume of 3 pyramids will fit inside the volume of a prism who has the same base and the same height. Now I want you to think about what that relationship means then in terms of a cone. So if you could say here, let's just say 3 pyramids are equal to 1 prism, what could we do to solve for a pyramid then? Well, I suppose we could multiply by a third. And since we already know what a general prism is like, that means to find the volume of a pyramid, you should take 1/3 of the area of the base, sometimes it's a square, sometimes it's a rectangle, sometimes it's a triangle, multiplied by its height. Now, in the same respect, if we're looking at a cylinder, if 3 cylinders fit inside of a cone, that would mean that one cone would be a third of the surrounding cylinder. Notice what both of these have in common is the 1/3 and the volume of the surrounding either cylinder or prism with the same base shape and the same height. So keep that 1/3 in mind as we go through this. Let's do a couple problems. All I have is 2 examples, as a matter of fact. Make sure you write these 2 down. If the volume of a pyramid, and maybe I should have written the area of the base times the height, but guess what the area of the base is? This appears to be a rectangle. Naturally rectangle, to find its area, you'd multiply the length times the width, and then we'd multiply it by the height. Now, for whatever reason, I often find the height to be the quickest dimension to substitute in, but we do have to be careful that if it's a square, you put in side times side. If it's a rectangle, you put in length times width. If it's a triangle, you put in 1/2 base of the triangle times height of the triangle. And by the way, that gets kind of complicated when you have a triangular pyramid, because you will find volume 1/3 area of the base times the height. That's the height of the pyramid, but how do you find the area of that base when it's a triangular figure? The confusing part there, it's got two different h's, it's got two different fractions, but remember, these dimensions are the dimensions of the triangle, the base of the triangle, the height of the triangle, and then the h would be the height of the whole pyramid. So that's a little more challenging than most of our stuff for today anyways. 1/3 times 5 times 6 times 4 ends up being 40 cubic meters. Notice, meters times meters times meters. We should be sure to have 3 dimensions when we're talking a volume. Now let's go onward to this right circular cone. The most important part, well, we'll write the formula down. But again, we better make sure we check this. Okay, 3 appears to be the radius, so don't double it, don't cut it in half. It is 1/3 times pi times 3 squared times 8. And when we do that, exact answer will be 24 pi cubic meters. Approximate answer, I noticed the previous teacher went to the nearest tens place. We're going to probably go to the hundreds place. Maybe we go to the tens place. We probably should figure that out, huh? So, how are these problems similar? How are they different? Both have a 1/3. Both have to figure out the area of the base. That was not as good on that one. Both have a height. Both have 1, 2, 3 dimensions. Radius times another radius times a height. Some people even write 3 times 3 times 8. Big difference here, ladies and gents. Exact answer for a pyramid, or at least in this case, there's no repeating decimal. Here we have both an exact and an approximate answer. One has the pi, one is all in decimal form. So that's what I have. I'm going to ask you in class to do a couple problems together. Just remember, make sure we are not using 3 and 1400s for pi. And because of that, maybe our answers will be a little off from the teacher's answers from previous years, but that's okay. All right, folks, that's what I got. Do well and let's grow. See ya.